Okay, we're going to finish our calculation now. I've kept the relevant numbers here so we can keep up with them. But we're looking for the two forces, and this is force 1, 2. Now you remember there was charge 2 down here, which was an opposite charge of charge 2. This was charge 1, and charge 1, if you recall, was negative. And so it's pulling on charge 2 downward at this direction. Now, we need to find out what that direction is. And so we go back to our 3, 4, 5 triangle and we ask ourselves, what is that angle right there? Well, you remember the inverse tangent of the opposite over adjacent would be inverse tangent of 3 over 4. That's 37 degrees. And so this is 37 degrees below the negative x-axis. Now you've been taught to measure all of your directions off of the positive x-axis. And so, and you start here and you start going around counterclockwise. And so we go 180 degrees to get to the negative x-axis and down 37 more degrees. So add these up, you get 217 degrees. So, at 217 degrees, we've got this much force. And we found this using Coulomb's law. K, Q1, Q2 over radius squared. And don't forget to square it, especially on a test. This is what students forget to do. Always on a test, or even on your homework, start with a formula. Because if you don't start with a formula, you'll forget that. Now, I mean, I do if I don't start with a formula, and I've been doing this for years. Also, once you get into this, I am ignoring this sign. We use the signs to tell us which direction the forces are going. This was a negative, that was a positive, so we know it was pulling this way. Up here we had a positive and a positive, so we know force 3, 2 is pushing that way. Okay? But once you've got those directions figured out, ignore the negatives for this calculation. And again, we figured out force 3, 2 using Coulomb's law, and it came out to 2 times 10 to the negative 4 newtons. Now remember, this is 4.3 times 10 to the negative 5 newtons. So if I wanted to put this in the same notation, remember this number, when negative 4 to negative 5, if this gets smaller, this has got to get bigger. And so we could also write this as 20 times 10 to the negative 5 newtons. Same thing. Remember, if this number gets bigger, that one has to get smaller. Negative 4 turned into negative 5. Now, once we found our forces, step 1, you remember step 2, part of step 1 was to figure out the components of that force. And so we look at our angles, and this is when we use them. Force 1, 2 was 217 degrees from the x-axis. So the x component of force 1, 2 is the magnitude of force 1, 2, 4.3 times 10 to the negative 5, times the cosine of that angle measured from the x-axis. And the y component is that force times the sine of that angle. So you take out your calculator, make sure you're in degree mode when you do this, especially if you're using a TI-84, because it may default you into radians, which we'll may use later on, but for now let's keep everything in degrees. If you start getting weird answers, check your mode. But, so we have, here's the x component. Now you'll notice force 1, 2 in the x direction is going in the negative x direction. And that's why we have a negative sign here. If you measure all your angles from the positive x direction, that will take care of the negatives for you. Likewise, the force 1, 2 y is also negative. It points downward in the y direction, making it negative. Now, force 3, 2 is in line with the x-axis. The angle is 0. And so you just follow the pattern. Force 3, 2 in the x direction is force 3, 2 times the cosine of 0, which is 1, so we get 2 times 10 to the negative 4, or 20 times 10 to the negative 5. The sine of 0 is 0. And as you can see, there is no y component here. It's all in the x direction. And now it's a simple matter of adding these up. So this force plus this force was 1.7 times 10 to the negative 4. This force plus 0 is negative 2.6 times 10 to the negative 5. You're almost done. The last step is to find the sum of the forces. And you are only using these numbers to do it. So the total force in the x direction squared plus the total force in the y direction squared. And you'll notice when you square it, it gets rid of the negative. So you should not get a negative force out of this. If you get a negative, something went wrong. And when we do this, we get 1.7 times 10 to the negative 4. That's the magnitude. So be on the lookout for problems that ask for magnitude and direction. And as you recall, the inverse tangent of the sum of the y's over the sum of the x's is all you need to do. And we come out with negative 9 degrees. That is the direction. Now, I would remind you, when we deal with angles and we're starting from the x-axis, we go counterclockwise, because that's how you were first taught to draw angles. A certain angle up from the x-axis was your angle. If it's going in a counterclockwise direction, that's a positive direction. But this time, we've got something going in the negative direction, negative 9. And what that means is our sum of forces went down 9 degrees. This was the sum of forces that we came up with. And it's in the same direction as the general idea we got from just drawing our vectors. You won't get it perfectly right every time, but it should give you an idea of what your final result should look like.